Thank you. Yes, so when Jonathan first reached out to me, I said, hey, I know this group because 20 years ago, I went to a meeting, I think it was a national meeting at the San Francisco airport at one of the hotels. It was a really impressive event. And so I was very happy to come back and join you guys tonight because I was always very impressed by what the organization does. So it was my uncle who was president a number of years ago. And in my family, all the men were engineers and all the women were programmers. So I grew up thinking that's how everybody's family was, and that's not the case. I found out, but I did end up going to Stanford to study engineering, and then when I came out, I spent the last 20 years in technology. So I did work at Intel. So for those of you who are in hardware, could you raise your hands? Working with semiconductors, okay. But then after that short period of working at Intel, I went into software. So I spent most of my career in software. And so how many of you are developers? Okay, or developers on the side? You may not develop at work, but maybe at home. Okay. So in that time I spent a lot of time at software companies like Informatica, companies like Siebel that were bought by Oracle, other companies, startups that were bought by IBM. So you can see there's a trend here. There are a lot of startups that get bought up and then some that make it and do well. But what I did is I also spent a lot of time working with standards organizations, and I just want to see how many of you work with a standards organization like IEEE or something like that? Okay, a few of you, great. So appreciate the work that is done in these groups because I think that's really important. So the reason why I say that is because as a beginning discussion around blockchain, we have to kind of come back to where we are. I mean, the blockchain technology is developing. It's early. And you can say it's a little bit like the way it was in 1890 with automobile technology. And at that time, people were just coming out with all different types of cars that were powered by steam, cars that were powered by electricity, cars that were powered by gas. And so there are a lot of different variations in this kind of technology. And you can say that is where we are with blockchain technology and kind of the willingness right now for a lot of people to look under the hood at how this technology works, how it interoperates with other related technologies. And the reason why I say this is because 20 years from now, or even 5 years from now, people won't be doing that. They'll just look at their phone like they do today and they just know it works. But now there is a lot of complexity there, and so there are a lot of terms that are actually overloaded. So since this is a technical audience, I thought I'd just go with some very basic definitions. But before I do that, just as a level set, how many of you have read about the blockchain, have heard about the blockchain, or done some project? Okay, let's start. First of all, just how many of you heard about the blockchain? Okay, great. How many of you read or researched it to, any depth? Okay, a few of you. How many of you done any kind of project with the blockchain, or blockchains? Okay. Okay, so good. So I won't go too much into detail, but just to level set, what the blockchain is technically is a way of storing data, and this data is linked cryptographically. Now, building upon that way, and that special way of storing data, are distributed ledger technologies. And distributed ledger technologies are immutable. They have peer-to-peer transactions that have been verified, recorded, without a central authority, and they promise to have more efficient transactions at lower costs. Now, cryptocurrencies then build upon distributed ledger technology, and specifically what cryptocurrencies add is this reward for securing the blockchain, and it's really a monetary incentive for securing the blockchain. So the way cryptocurrency works is, and this is an example of how a transaction is added to cryptocurrency, two parties wish to conduct some kind of transaction, and this transaction could be monetary, or it could be some kind of change of ownership. And so to illustrate that point, I know we talked earlier today about voting. So how many of you have heard of blockchain voting? Okay, none of you. All right, so voting is a transaction. Exchanging real estate is a transaction. So all these are transactions that you could perform on the blockchain. So while this is a monetary example, I just wanted to highlight the fact that a transaction on a blockchain could be a number of things. And so in this case, we're looking at A and B wish to conduct some kind of transaction. Cryptographic keys are assigned to the interaction that both A and B hold. So A and B each have private keys, public keys, and the interaction is broadcast and verified by a network when they do this transaction. Now, once validated, once this transaction is validated, then a new block is created, and this block is then added to the chain, creating this golden source or this immutable record that you can always go back to for auditability, for compliance, or any kind of reporting. And that's when the transaction is completed. Now, the reason why the blockchain is so powerful is because three main reasons, or I boil it down to three main reasons. First of all, the ability to handle decentralized transactions. So decentralized transactions means you have much faster settlement because you eliminate third parties and you can do this all at much lower cost. So in my 20 years, I spent a lot of that time with banks. And with financial institutions, I spent a lot of time with SWIFT as an organization. How many of you have heard of SWIFT? Okay, so SWIFT was great, came along in the 80s and said, hey, everybody has to go through us, and you only have to solve one side of the problem, right? Just translate, transform your data and go through us. Now, that works well. The challenge is you are going through SWIFT. SWIFT is the central party, the intermediary, and they pay, or they cost a lot. They force people to pay a lot in order to go through that. Now, SWIFT was really just a messaging network because underlying this network, money was actually still exchanged bank by bank. So if I need to send money from here to, say, China, it will go from my bank here, maybe in Cupertino, to the Bank of Ohio, from the Bank of Ohio to the Bank of Montreal, and the Bank of Montreal to the Bank of England, and the Bank of England to maybe some bank in India, and then finally, to China. So my point is there's just a lot of hops along the way to actually get the money across. Now, each time there is a hop, that means somebody takes a cut. So that is why, in the end, a lot of these payments that go from here and across borders are so expensive. The second big reason for the blockchain is transparency. And that is now because everybody who has access to the data can see this information, it's completely transparent. It's like a giant Google spreadsheet that you share with everybody. But of course, the blockchain is more sophisticated in the way it handles permissions and controls. So not everybody can see that data, only the people who have the access. But the point is now you don't have to be sending spreadsheets around like we used to in the 80s or 90s. You're able to really have this transparency without that waste, without that end-of-day reconciliation that costs corporations, costs banks, costs a number of companies a lot of wasted time. And this was something actually when I was in Informatica. And how many of you know Informatica? Okay, just one of you. So Informatica is a company that is a software company, and what they specialized in was moving data around. And that was a big problem for many companies. And that end-of-day reconciliation, or that reconciliation, was what caused a lot of headaches and problems. So the last reason why the blockchain is so innovative and the technology is so innovative is the security. So built into the blockchain is this cryptography, state-of-the-art cryptography that isn't available with a lot of the traditional databases. And the way the blockchain is structured and the way data is added to the blockchain enables it to be more fraud attack resilient, and helps a lot in reducing fraud. So I'm not going to go into a lot of those details because I think you can find out that information very easily on the internet today. There are a lot of really great examples and articles on, the benefits of the blockchains. But what I will go into now is what we've seen at BlockCypher. So BlockCypher has been around for almost 5 years now. We've been exclusively focused on blockchain technology and helping startups and companies develop their new applications. So developers, so those of you in the room who are developers, you are a target customer. We develop APIs, we have an infrastructure that enables you as developers to quickly create new applications, test them, and then roll them out in production. So here's a partial list of our customers. We, over the last 5 years, have over 20,000 different developers and companies using our APIs. Some of them have come from very small companies, 1 or 2 person companies. And some of these companies have started off small, like Coinbase. How many of you have heard of Coinbase? Okay, a lot of you have heard of Coinbase. Coinbase started off small, but then, over the last few years, it's grown into I think a $1 billion company. And then very large companies will use us for a number of reasons, like the U.S. Department of Homeland Security, AT&T. We just completed a project with the Department of Energy. And all these organizations are looking to use a blockchain because of the inherent complexities that I started off talking about, right? So blockchain versus distributed ledger versus cryptocurrencies. Now, the unique role that BlockCypher plays enables us to see how all these blockchain applications are being developed. And that's because BlockCypher sits in the middleware layer. So we are middleware infrastructure. We sit between these applications and the different blockchains because what we found is these different applications need to access multiple blockchains. And the reason why these different applications need to access multiple blockchains is because each blockchain has inherent weaknesses and strengths because of the way it was built. And because of these inherent strengths and weaknesses, these blockchains are now used for different use cases. So I'll give you an example. How many of you have heard of Bitcoin? Okay. How many of you have Bitcoin? Okay, few. Right. So in the beginning, 2008, 10 years ago, right, people had Bitcoin and they were using Bitcoin. To this day, companies still get Bitcoin as payment, but not as much as they used to. Why is that? Well, that's because Bitcoin, instead of being seen as a payment system or a form of payment, is now in a payment system, is now being seen as a store of value, like gold. So a lot of, and I always find this interesting, but I can look through all our customers and we see more of these gold and silver type companies adding Bitcoin as one of the assets that they trade, store, for their customers. But the point is, Bitcoin once was used for payments, but now it's largely used to store value. Why is that? Well, that's because Bitcoin has high fees relative to some of the payments people want to send and slower transaction time. So think about it this way, like you have cash, you have credit cards, and you have the choice of sending money via wire. Would you send money through wire every day? Probably not. If you're going to buy a sandwich, you might use cash or you might use your credit card. And then depending on which mileage program you're using or point system you're using, you will use a certain credit card over another one, right? So people all have different preferences for the way they pay. And we're seeing, and that's a simple example of payment, but that's what we're seeing come out with these different coins. So, or these different cryptocurrencies. So Bitcoin, store of value. If you want to make fast payments, you use Dash or you use Litecoin because those networks have lower fees and much faster settlement time. Now, on the other hand, if you are trying to do something in the blockchain that requires more sophisticated logic, like a contract, you would likely use Ethereum, because Ethereum has developed this really comprehensive smart contract capabilities. How many of you have heard of Ethereum? Okay, a few, yeah. So Ethereum is now used by a lot of companies to do, say, supply chain management, handle contracts for trade finance, and those kinds of things. So Walmart, as an example, is using the blockchain to make sure that the food in its supply chain is of a consistent quality. So the fish, let's say that I send from here in the US to Korea, as an example, stays the same temperature the entire time, and I can make sure that it does, and only pay out for the fish that stayed the same temperature the entire time, 0 degrees Celsius, if I see that reflected in the blockchain. So anyway, so Ethereum is widely used for contracts, and then Hyperledger. How many of you have heard of IBM's Hyperledger? Okay, Hyperledger is used for the supply chain use cases, and Ethereum is as well. So there are just a number of different technologies that are used for different use cases. So now I'm going to go into payments and financial use cases, and the reason why I start here is because this is where a lot of the use cases started for blockchain. And that makes a lot of sense because Bitcoin, like we talked about earlier, was one of the first blockchains to develop, and it became very popular for the payments use case. Now, beyond payments, you can look at payments cards, you could look at foreign exchange, cross-border payments, but there have been other use cases like identity management, blockchain as a service, ICO funding, and how many of you have heard of ICOs or ICO funding? A few of those, okay. So that's a really interesting use case because here you're taking the crowdfunding idea and instead of having to go through a VC, a traditional VC, now you can get the money from all different people around the world. Now, beyond though, these financial services use cases, which are easy to understand because of the origin of blockchain in payments and Bitcoin. But beyond that, there are a number of other use cases. So how many of you here are in healthcare? Okay, none of you. Okay, so then I won't go through that use case. How many of you deal with devices of some kind or are in energy? Okay, then I'll go through this one. So we just completed this project with the US Department of Energy, and in this project we were showing how two homes could send each other energy. So let's say I'm Jonathan's neighbor, or I live down the street for him, and he has a solar panel and I have a Tesla. I don't have a Tesla, I wish I did, but let's just pretend. We're pretending, so I'll pretend I have a Tesla. But I don't have a solar panel and I have a lot of trees. And the city of Cupertino, let's say, says you can't cut down your trees because we're Californians and we love our trees. But I need to power my Tesla. So I can, and this is what we're trying to prove out in this project, I can buy energy from Jonathan and he can then earn basically a profit from that. And what we found is that an average home in Palo Alto, given all the different conditions, the weather conditions, energy that you have to use for his home. So for a 5 kilowatt system that he were to have, he would make $432 a year by selling energy, say, to me and others. And we, through this project, built an application using 4C, which is their home energy management system. And we leveraged BlockCypher's APIs because BlockCypher has a platform, a testing environment, but most importantly, we can support multiple types of blockchains. And before I go into why that is important, let me just describe how this works. So in this lab, we had one test home representing Jonathan's home, another home representing my home, and we had all the major appliances like dishwasher, washer, dryer, dishwasher, dryer, HVAC, PV, and we had a PV and battery. And what we were simulating here is how the seller, say Jonathan, would be sending me energy, and then I would be paying for it. Now, before all of this happens, before all these transactions happen, Jonathan and I would have to establish a contract. Now, we could do that very simply and just say, hey, what's the price I'm going to give to you? Or we could do this on a marketplace. So, working with the Department of Energy in this particular group, we believe that in the future there will be, or there can be, this marketplace where people decide on what their energy contracts are, how much energy they want to pay. Now, in that case, there's a lot of rules that go on, what's the market price for the energy, what do you think you can get for it now versus later. So there's a lot of complexity, right? And so setting up a contract is more complicated than just saying, hey Jonathan, what do you think the price should be? And in that case, you might use or create a smart contract using Solidity code, and that would be on the Ethereum network, right? So this marketplace would be something that would be administered through the Ethereum network. So the first API then that would be used is an Ethereum API, and that's to establish that contract. But now once the contract is established, now I want energy from Jonathan, he wants to send it to me, and I should pay him. That kind of an interaction needs to happen on a network that's very fast and has very low fees. Because energy, small amounts of energy, small transactions need to be fast and need to be very low cost. Ethereum as a network is not so great for that now. They're great for these contracts, but not for that performance and not for those low fees. So that's when we switched to a different network, a different type of blockchain technology, and that was the Dash blockchain. So Dash and Litecoin were the ones I mentioned earlier that were more well-suited or better well-suited for faster transactions and lower fees. And so what we proved in this scenario is that there were two types of transactions that we could send and that were needed for this kind of a scenario to work. The first transaction is settlement. Obviously, I need to pay Jonathan for the energy that he sends me. And so that's very simple to understand. Okay, I pay him and he's happy. But I also need to know that he sent me the energy that he was contracted to send me. Because if he doesn't send me that energy, then I'm not going to pay him anymore. And likewise, if I don't pay him, then he should stop sending me energy, right? Because those are the terms of the contract. So the first type of transaction is settlement. I need to pay him. The second type of transaction is an energy receipt. And that receipt shows that Jonathan indeed sent me the energy that he was supposed to send me. And that energy receipt now is recorded in the blockchain. It's immutable. You can track it, and it can't be changed. So those things are important because we're dealing with utilities, and whenever we work with utilities, we do need to, we're using the grid and we need to pay out a fee to the grid. So there were a lot of things that we worked out, but I won't go into detail, but I'm happy to talk to you later about how we ensured the utilities were paid or were compensated for their involvement in this kind of peer-to-peer energy transaction. But what was really exciting to see is that this can actually happen, and it can happen with a number of automated capabilities and fees paid out to the parties that need them. How many of you deal with analytics or run that part, or just do analytics in your life? Okay, you do. So, so what's been really fascinating about the blockchain and why people are so excited about the blockchain in terms of analytics is because there's all this data now that is there. And we've been working very closely with a company called Blockchain Intel to develop a lot of these algorithms, these different ways of reporting. So I'm not going to take credit for all the work that I show you. I'm just going to say that we've been working with them and we work with a lot of partners. But I do want to start with blockchain data complexity. Now, there have been a lot of people over the years who say, well, the blockchain is a scary place, or cryptocurrencies are scary because you don't know who anybody is. And the fact is that's not true. So with Bitcoin and all of Bitcoin's related sisters and brothers, they're all pseudo-anonymous, meaning you can actually figure out who's who. It's kind of like a phone number, right? Your phone number may not be immediately apparent, or it may not be immediately apparent that the phone number belongs to you, but if you call somebody, they know who you are. And while that's true, there's some other complexities about the blockchain and the way the data is stored. But that fact alone enables companies like Blockchain Intel to figure out who's who and be able to identify where there's crime happening, who's doing most of the scams and the different hacks and things like that. So using this data and understanding these behavioral patterns, Blockchain Intel and BlockCypher work together to solve some cases to find out, who is hacking into or who has stolen certain funds. And then using that information, really identify the IP addresses and then the individuals who have done these different crimes. Now, the analytics can also be used to identify where growth is happening, where certain trends are happening. So by looking at the blockchain, the activity on the blockchain again, you can see the behavior, see where things are occurring. So I'm going to, like we talked about in the very beginning, by no means are we all developed and everything is perfect in the blockchain world, right? There still needs to be a lot of work. And there's still some fundamental issues that have to be addressed. And so some of those issues include scalability, privacy, and accessibility. And some of you, if you've looked into the blockchain debate, have seen how people ask, well, how can this be scalable? How can we actually have 43 million records, for example, of customer data replicated all around the world? Right, so scalability is a question. Privacy is a question. So we talked about before, things are pseudo-anonymous on many blockchains. So how do I know that my very private bank account information is not being shared with everybody in the world? Right? And then finally, accessibility. How do we make this easy to use and accessible to everybody? So there are some new blockchains coming out. Notably, one that is coming out early next year called Grin. And Grin is one of the blockchains that we believe addresses a lot of the issues I just talked about: accessibility, privacy, and scalability. And for that reason, we have started a mining pool, and we are donating the funds, a portion of those funds, from this mining pool back to the developers who created this, because we believe that this type of blockchain really does move the whole industry forward. And it is one of the blockchains, like the other ones that I mentioned, that we'll develop APIs for. So my point here is just, we're not done with blockchain development. There's still work that is being done and that needs to be done, but the good thing is, and the amazing thing is, that there are so many developers out there, so many people out there who are committed to creating the next best blockchain and making blockchains more ubiquitous. So what if there's only one thing that you take away from the session, I'd say take away that you can get started today, meaning you could literally in the next 3 seconds start sending your own blockchain transactions and putting things on the blockchain. And the way you do that is just by signing up on our website, your name and your email, and you'll get a token. And when you get a token, you can immediately start sending transactions. And I do this all the time when I'm just using my Mac, and I just open up my terminal and I send curl commands. And so it's really easy. You start off free, and then as you use more, you pay more. It's very much like a cell phone plan. So all the companies that have started small with us and have gotten bigger started this way. So I'm just going to show you a really quick example of how this works and why our APIs are so powerful. So if you are a developer today and you want to use 5 different blockchains, and the reasons are, like I described before, right? Each blockchain is great for 1 or 2 particular things. So you will want to use multiple blockchains. Use Ethereum for contracts, maybe Dash or Litecoin for payments, and so forth. So the way our APIs work is, as a developer, you don't have to worry about all the details of how each blockchain works. Because these blockchains are different. You don't have to set up your own client. You don't have to set up your own node. You don't have to maintain all that. You can just use us. And as an example here, the API calls are very similar. I mean, they're basically identical, meaning if I want to send a transaction on Ethereum, it looks identical to sending a transaction on Dash, because all I'm changing are 3 letters that designate the chain that I'm using. Everything else is the same. So for a developer, it's reuse, and that's wonderful because now I don't have to deal with a lot of different details. So in this payments example, and I would show you if you want to see it later, I can show it to you live, but I can create an address for myself, which is basically saying I create my own bank account, right? Like you don't have to go to the bank to create a bank account. You don't have to go online to create a bank account. You can just create your own bank account within a second. And then you can create your one bank account, you can create another bank account, create as many bank accounts as you want. In this example here, I'm saying I'm using our test environment, and I'm able to give myself, because I'm testing, right, $5 million. And when I want to send money from one address to another, I just create a transaction with the transaction API. So my point is, these are all APIs. I didn't have to sit here and code a whole bunch of stuff. I just call an API. It's just one curl command, and I'm done. And then I create a transaction. So I've created my accounts, I've funded my accounts, and now I'm creating transactions from one account to another account. And I have to sign that transaction and add the signatures for the public keys, and then I can send the transaction with our send transaction endpoint. And then now I'm ready to actually check that transaction, and I would see it immediately appear on the block board that I showed you either. It would be immediately added as a transaction within a block within seconds.